Okay, I'm just gonna try to get all this stuff back here for us. There we go. And get us to this website. I want to show you an example of how AWS works with SoundCloud, which I'm sure you've heard of. This is the Amazon Web Services site. This is a case study, 2014. So, this is a quote from the VP Engineering. So basically, SoundCloud, um, users can upload 12 hours of audio material to, to its platform every minute. That's obviously the musicians. And each one of those files, as you can see, has to be stored in multiple formats. And they are analyzing billions of events daily. That's called database marketing, folks, to understand user behavior. And they're always trying to optimize and give each person what he or she wants. And as of 2014, they had 2.5 petabytes of data. Okay, as you can see here. Global audience worldwide, active 24 hours a day, highly inconsistent load profiles. Okay, load spikes occur when users in Europe and US use the platform at the same time. The storage crash, that'll be the end of SoundCloud, they say. So they don't want to be in the data storage business. They want to be in the delivering great music, getting and delivering great music to people. So SoundCloud went to AWS to store and process the massive data sets that are uploaded every day. And so they use Amazon S3, which is simple storage service, and Amazon Glacier. Amazon Glacier is the cold storage. That's the cheap stuff with no uninterruptible power source, UPS. So the files that they get are stored with Amazon, all the audio files, all of them, and distributed from Amazon via to listeners via the SoundCloud website. Then they copy every file to Amazon Glacier to make sure the data is available. Data are available. They have 2.5 petabytes stored on Glacier. So, quote, we don't need to worry about storage. AWS lets us sleep well at night. Okay, they handle load spikes using Amazon Elastic Compute Cloud. Okay, spikes in transcoding loads are distributed throughout the day. So they are the pipes to the data. If a lot of people want the data, Amazon has the ability to expand, make the pipes bigger so more data can travel quickly. Things don't slow down, in other words. User experience stays good. The download time for the user is kept the same no matter how many people are downloading. So that's what they do. They don't need to buy and manage their own servers. Um, and that's that. And so a little bit about storing data. Let me close this out. So go back to Screencast-O-Matic, of course. And let me take this here and here. Oh, so I think Billie Eilish started on SoundCloud, didn't she? I don't think we need to play that though. I love it, but okay. There's a data storage center, everybody. That's what the cloud looks like. It looks like a big warehouse, which is what it is. Full of servers. All right. And you see there are hardly any cars there. You don't need a lot of people. Remember this, the whole idea is to store cheaply. If you've ever done a storage unit here in the city or elsewhere, they don't have lots of employees running around. See all the trees. Okay, so the real estate is cheap. There are not a lot of people, but that's a data warehouse. Amazon has them all over the world. That's what a data storage room might look like with all the servers. Okay. By the way, here is let's see, this is done by Greenpeace, I think. Yeah, Greenpeace. had an airship, 135 feet long. They flew it over the National Security Agency's data center in Bluffdale, Utah in 2014 to protest their mass surveillance program. So NSA illegal spying below Greenpeace. I mean, I don't know who saw that, but they took a picture. This underlines a little bit that these data centers are potentially kind of vulnerable, folks. Yeah. Here was this is an article. This happened a couple of years ago that Amazon won. No, no, they didn't win. I think IBM won a huge cloud computing contract from the government. I think it might have even been the National Security Agency. And Amazon got pissed off. Jeff Bezos thought that Trump told the people bidding the job not to give it to Amazon because Trump doesn't like Jeff Bezos. Jeff Bezos owns the Washington Post newspaper, and Trump doesn't much like that newspaper. It's not very nice to him. Uh, uh, anyway, um, Amazon sued when the government awarded it to IBM, this $10 billion contract, and you'll have to look up where that stands now. Go ahead and Google it. I think there was a ruling in the suit. These are just making the point about the worldwide storage. These are the locations of some of Amazon's regional data centers. You see Japan, you see India, you see uh, South America, Australia, a lot in Europe. Don't see any in Russia. I don't see any in China. Okay. So that's getting us to think about the cloud and data storage, what's really involved. So when you talk about, we get all this service free from Facebook, what does it cost them? Well, look at all the data they're storing. You don't think that costs? Yeah, it does. I now want to talk about another important aspect of databases. Um, and this has to do with what's called a relational database. So the databases that you'll be working with in your careers are really all going to be relational databases. There are two basic database setups. One is called the relational database. We're going to get into that more in a minute. The other kind is a hierarchical database. Say that fast 3 times. Hierarchical database. I don't know, do we have a definition here? No, not too much. It's one big database, lots of information. Um, this is hierarchical. It only goes in one direction, the information. Um, I almost think a better illustration of this would be a huge Excel chart, as long as the FIT campus between 7th and 8th Avenue of an Excel chart, if you can imagine that, with all these different columns and rows and titles for each one, and you're gathering all this information about people and you're putting it in there. But what's going to happen, for instance, imagine an Excel chart where you're gonna capture data on people's favorite hobbies. Okay. And the left side is a is people's names. Okay. And you've got 10,000 people, let's say 10,000 names. Those are the rows. The columns are the possible hobbies they could have. How many hobbies are there, folks? I don't know. It's hundreds, thousands of hobbies. Okay. Knitting and horseback riding and yeah, etc. I mean, that's all I can think of right now. But anyway, so if you had, that'd be a hierarchical chart. If you put an X in the box So Fred knits, but so he gets 1x, but then he doesn't do any of the other 2,000 hobbies. So on the Fred row, you've got one box with content in it, and the rest of the cells of the boxes are empty. So what do you get with a hierarchical database? You actually get a lot of open boxes, blank cells, which means a lot of storage space is wasted because a cell is a cell. If you have the cell, it's taking up space. Have you ever defragmented your hard drive? That's getting rid of open cells, wasted space, okay, if you've ever done that. So what does hierarchical database means? Wasted space, which costs money, number one. Number two, it takes time because if you do a query against a database like that, it's going to have to look at even all the empty cells, have to be looked at, and that takes time. So we have what's called a relational database like this, where we break our data down into like uh, chunks of data. I'm going to stop here, so I'm not sure how much time I've taken. I actually have a few more minutes on this, so I'm going to keep going. Relational database. So this is a bank's relational database, and there are different chunks of data, like alike data. Here's employee data. There's customer data. You can see account data, branch data, manager data, and each chunk is full. All the cells are full, and they are linked by having the same information in several different chunks. For instance, the link between the employee chunk and the manager chunk is manager ID number. You see the little line there. The link between employee and customer is the employee ID number, et cetera, et cetera, et cetera. So what does this mean? This means I don't have open cells. The cells are full. And that means storage is cheaper, and it means queries are faster. And we may be only talking a few seconds, but a few seconds matters. So that's a relational database. Now, the way a customer database looks, I think that's what we have next. Yeah, okay. This is a typical customer database setup. Got an operational database that does all the transactions, sales, shipment, payments. We've got a marketing database, which has information. This is where I do my analysis. And the two are linked by customer ID number. So I have all the deep information on my customers in the marketing database, but I feed transactional. If you buy something, I'm going to add it to the marketing database. Okay. But the operational database is very different. It's running the business. It's taking orders. It's taking payments. It's sending shipment information. Chug, 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 chug. It's going along very fast. The marketing database is more for analysis. It's where I segment my customers. It's where I find my most valuable customers. And it's where I set up communications. You can see promotions and responses, where promotions are coming out of there, surveys are coming out of there. Okay, and then it kind of goes around, and there's a website on one side, and it creates transactions if people do something when I send a promotion, and then that goes into the operational database. So this is a simple model of a marketing database. Okay, folks. Okay. It runs like a nice little engine. The marketing cycle is, I get smarter every time when I send out promotions, folks, and I always send out some tests, okay, and I look for a higher response rate from a different subject line. That's what I'm going to expand the next time. So that's why there's a cycle. Every time I do something, I test options. Testing is very important to direct marketing. And then I learn and I expand whatever works better. So I'm going to stop here.